All right. It is 7 p.m. Here in Austin, which means it is time to start this month's edition of Merge PHP. Welcome to folks tuning in on the stream, wherever you happen to be. Merge PHP is a group of PHP user groups across the US that have banded together since 2020 to uh, you know, talk about things and learn things. So we'll get right into it. But first, a logo wall. Also, if you don't already have a PHP Storm, the JetBrains license raffle is a good way to get it. It gets you 1 year subscription to any JetBrains product, whether that's PHP Storm if you don't have that already, or one of the language-specific or even general IDEs that JetBrains has on offer. Whether you're writing code on your own or having the computer do it for you, or picking up the pieces after a large PR comes in from dubious sources. I still use PHP Storm in my day-to-day, and it definitely pulls its weight. So, um, hop over to your email client, send Chris an email. First one in, maybe second one in, and third one in, depends on how many licenses we still have. Gets a JetBrains license. Thanks to them for their support. So the current version of PHP is 8.5. Both 8.5 and 8.4 are actively supported. 8.3 and 8.2 are still receiving security fixes. If you are on 8.1 or earlier, then unless your Linux distribution is backporting security fixes, you are on an EOL version of PHP. And if there are security issues that come up, which these days is a bit more likely with bots coming over the code, best to make sure that you are running a supported version. 8.6 will be released toward the end of this year, but right now we've got 8.5 and 8.4 active support, 8.3 and 8.2 security fixes only. So there are a bunch of PHP conferences and CMS-related conferences that are on the docket. Various WordCamps. Laracon in Boston is coming up later this month. Got DrupalCon, got Laravel Live, and then one that's relevant particularly to me, Longhorn PHP, is October 15th and 16th this year. We extended the CFP on that one, so it closes tomorrow night. Get your talk submissions in now, if you haven't already, and hopefully I'll see y'all in Austin in October. Otherwise, PHP Tech is April of next year in Chicago. We are on various socials, particularly when I remember to post, which I will be doing slightly later. Best place to catch up with us is on YouTube, where you're probably watching this right now. You can also go to mergephp.com to see upcoming user group topics. For example, next month, we'll be looking at different version control system than your usual Git, Jiu-Jitsu, courtesy Nick Vihalik. You can find more information on this on the Merge PHP website if you're not going to read this quickly enough before I change slides. If you have a talk idea, I believe we have maybe September, I think is open. Go ahead and find us on socials. Submit that talk idea. We would love to hear it, whether that is a full-length talk, or we can probably squeeze in a lightning talk at the beginning of the month's presentations. with that, I'm going to turn it over to Joe Ferguson, and we're going to dig into Ansible today, because doing the DevOps is important for keeping things reliable and online, and preferably not waking you up at 2 a.m. So I will unshare my screen in a second and hand it over to Joe. Alrighty.
All right. Thanks, Ian. Okay, here we go. So welcome to Ansible for PHP developers. This is a hour, 50 minute to 60-minute hour-ish talk. I may go a little bit fast. I may go a little bit long, depending on if there's questions or if people want to see something explained in a little bit more detail. What our goal is tonight is to spend some time looking at Ansible and how it can help you manage your servers and configure and provision servers. So for that example, what we're going to do is we're going to start with the task of we're going to provision a bare server and we're going to ship a modern Laravel application. This also works with Symfony. It's not framework specific at all. Ansible is actually very little PHP, if any at all. It's mostly Python. So what we're going to do is we're going to provision the server, or we're going to set up a deployment. We're going to set up a playbook that will do some system updates for us, and we're going to dive into the details of how all this happens with Ansible, why it happens, why it's safe, and how it can make your life a little bit easier if you're managing servers or infrastructure. Who I am and what you're going to leave with tonight. My name is Joe Ferguson. I'm a PHP developer, Linux enthusiast. I do a lot of DevOps. I work for PHP Architect. We have a magazine. We have a consulting business. We do a lot of different things. We also do a conference in Chicago every year, so you can check that out. So what we're going to start with is a bare Debian box. And we're going to get it up and running with the Laravel app, and then we're going to show you how to do zero downtime deployments. And hopefully what you leave this talk with is a better understanding of how to leverage Ansible for your needs and why it may be the right tool for the job, or it may just be another tool in your tool belt. The real focus here is kind of what does a playbook look like, and how can you leverage the automation aspects and the idempotency aspects of Ansible to manage your infrastructure. So a lot of people who have been who have been sysadmins or been developers for a long time and have been managing servers for a long time kind of know this aspect of deployment strategy, which is SSH and hope. You SSH to a host as a user, and you run a command, and you hope it installed Nginx. You hope it did the thing. You added the -y flag to the apps package manager, so you know it will automatically install the package for you, so you know Nginx will get installed. But all this is you're hoping that it worked. You're hoping that it ran on the host that you expected it to run on. And you hope you remember what you did in 6 months. Did you install Nginx? Did you install a specific version? What app repository did you install Nginx from? Did you roll your own and compile it yourself? So all of these are problems that Ansible can help with. And this is also very much brings in the cloud native philosophy of treating your servers like cattle and not pets. Meaning that you don't want special Snowflake servers. You want to be able to replace a server and not have any emotional attachment to it because it's just doing work for you, right? It's not the lovable cat. It's not the faithful dog. It is the cattle that performs work and does something valuable, hopefully for you, and gets you paid in some way. Whether it's selling a product, running a CMS, running a consulting business, running a magazine, any of those things. So the real kind of cost of the Snowflake aspect of SSH and Hope is what you get with you get config drift from host to host. So you may get different Nginx versions, you may get different versions of PHP, you may get different versions of any number of things. What you actually want in that aspect is you want every host identical, and you want them to be identical on demand. Like you want to be able to run a thing, run a tool, and know what's going to be on the other side of that tool is a server in a specific state. You also have the works on my box, and with Ansible, what you actually want is the box is the spec. The playbooks and the documentation that you write around Ansible becomes the spec for the running server. Your SSH and hope is also often unrepeatable because you didn't document the steps, or maybe you did write a giant bash script that was very brittle and worked once and you never went back to fix it up, right? How many of us have written proof of concepts that went straight to production, right? It's that kind of aspect of making sure that everything is repeatable. It's also what you really want in that is not only that you want repeatable, you want it to be safe to repeat. You want the idempotency of you can run a command and then you run the same command, and if nothing needs to happen, nothing happens. That's what Ansible gives you. The last thing is tribal knowledge. All of that tribal knowledge that you have in your brain that you may walk away from when you leave your job, or that other coworkers that you work with may leave, and you lose that tribal knowledge. And what Ansible does is that playbook that you build is the documentation. Kind of like a lot of people say, the well, I don't need to write documents. My code is my documents. You know, it's not that same level. It's not the same. It's not as good as documentation, right? But you at least know and can discern the server state from the playbooks. So it's not like you're just inheriting a server, somebody's throwing you some SSH keys and saying good luck. It's very much a, you know, the starting point, you know how to immediately work with that server if it's already been backed by Ansible. So, what is Ansible? It's essentially agentless. It only has a couple of concepts. It's agentless, which means there's no application that you have to install and configure on the remote server before you start working with it. There's a concept of inventory, which is how you group servers and assign values to servers, and essentially state and describe servers that you want to interact with via Ansible. There's also modules and tasks, which are how actual work units get done. And you can group tasks into modules, and you group modules into playbooks, and it kind of all trickles down in a very easy to understand and follow way. The big thing that I keep mentioning is idempotency, being able to run the same playbook over and over and not breaking anything. Playbooks and roles are how we're gonna manage our modules and tasks. It's how you keep them grouped together and how you keep them focused. We'll have specific roles that do specific things, and we'll have a playbook that utilizes multiple roles. When we say agentless, you can just SSH into any host and run Python 3 on it. You can run Ansible. The the easiness of this can't really be overstated. Most cloud images of any Linux distribution that you spin up today that are modern are going to have Python 3 out of the box, and they're going to support SSH almost out of the box. At least cloud images will. So any system that you have that you can SSH to, you can connect to it with Ansible. And that includes services and hosts behind jump boxes, Bastion servers. If you can SSH tunnel to it, you can connect to it and run Ansible on it. And you can use Ansible to provision the server, install software, anything you can do with Ansible, you can do it. It's all happens over this SSH connection. When you compare Ansible to something like Puppet, Chef, Salt, other tooling, there's an agent installed. You have to have that agent on the server, and that's one of the first things you have to do. You typically bootstrap that when the server is first created, so you already have that up and going. Ansible's doesn't have any agent, and there's also means that there's no application to exploit that can be leveraged to gain access to your infrastructure. The only thing that can break into what Ansible uses is if something breaks SSH. So as Ansible can handle your bare metal, it can handle VMs, it can handle cloud instances, it can handle any mix or any mash of combination of those that you want to use. It'll work. It works with on-prem, off-prem, anything you have SSH tunnel to, you can use with Ansible. So the control node and the managed nodes are concepts of Ansible. It's essentially where Ansible is being executed from and what it's doing, and where it's doing that work on the remote system. So if you're running Ansible yourself on your own machine, the control node is your machine. And a managed node would be any of the web services or any of the hosts that you're managing through Ansible. In our diagram here, we've got Web 1, Web 2, and Web 3. Maybe these are three application servers in a load balanced pool. Those are our managed nodes because they are being managed by our Ansible playbook. There's no agent, just an SSH listener and Python. When you get into more advanced Ansible setups, your control node can actually become a VM itself, or it's running in a Kubernetes cluster. Something we could talk about a little bit later is AWX, the Ansible. It's essentially a Django app that has Ansible ways of running Ansible playbooks. It's a really great way of once you start managing dozens of servers to move your Ansible playbook running from any one person's machine and into the cloud or into your running infrastructure to be able to better manage it at a larger scale. But for what we're doing and for what our kind of purposes are tonight, I'm just going to show you, assuming that you're going to be using your laptop as a control node. The real power of Ansible is this inventory and this and essentially the descriptive nature of everything. You're describing what you want in an Ansible's conventions of what you have as far as your server inventory. So in this example, we have two web servers. We're going to have a DB server, and then we're going to group them into groups. So just like in the first bracket section, we have web servers. And we can then reference these hosts by just using web servers. So if we want to run our PHP installation, we would run that and we could target our web servers, which is a group of in our inventory. So those roles or those playbooks would only run against those hosts. Same thing with DB servers. And then now we can have production. Production is a group, and the children of production are the groups within web servers and DB servers. So you can have this very complex relationship built into your inventory. You also typically want to describe your connection preferences or connection statuses or how you connect to these different hosts in your inventory as well. We also have an example later in the talk showing you how to do even more granular variables. So what we're saying in this inventory file is web 1 and web 2. We're specifying these IP addresses, and then we're specifying the Ansible underscore user that we're going to connect to. And that is the remote user, the remote Linux user or system user that has access to do the things that we need to do. I typically do everything as root just because it's easier. If you need to SSH in as a unprivileged user and then sudo everything, there are ways to do that. It's called become or become user. There's ways that is easily handled. So don't think that if you don't have root access immediately that you can't use Ansible. It's totally something you can do. We're just showing you this for simplicity. There's also all. There's just an all keyword that you can use and that will run against all the servers in the inventory file. The next concept of Ansible is modules and tasks. These are our work units. A task will run a module with arguments, and modules and under the hood are Python scripts. So if you've ever dealt with Python or if you've ever worked with Python, you feel right at home looking at some of the source code for these modules, and a lot of the conventions will make a lot of sense. If you've never touched Python, you're not missing a whole lot. Trust me, you don't need to know Python or really much Python at all to understand Ansible. So what we're doing with this task is we're using the apt module, which has a fully qualified namespace. It's ansible.builtin.apt. You don't always have to use these fully qualified collection names. FQCN is what they're called. Different versions of Ansible have different strictness levels of that. So if you want to be very strict, you use the fully qualified collection name. If you want to be less strict, you can just say apt, and most Ansible versions and playbooks will use that as well, kind of like a fallback. But more modern, later versions will be more strict about that. So we're passing two arguments here. We're passing name and state. We're saying we want the apt module to have the package named nginx to be present. So the name is, and the name of this module, the name of this task is install nginx. This is just easily human readable. This is what you're going to see when you run the playbook, and this is just one example of hundreds of different modules. There's a file module for creating and editing files. There's a user module for creating and editing users. There's also templating where you can generate files on the server based on a template. It uses the Jinja 2 templating engine. So if you're familiar with modern templating engines like Blade or Twig or even if you're familiar with Jinja, it's very similar. You should feel pretty at home working with these. You can also use the service module, get MySQL. There's just so many different modules, and these are all how you do things. So if you have the idea of I want to do X in Ansible, how do I do it? You search for the module. I want to install Nginx. How do I install that? I'm on a Debian system. You use the apt module. If you're on a Fedora system, you'll use the DNF module, maybe Yum. So there's modules out there to do almost everything. And if there's not, there's a module that you can just run shell commands. So as a last resort, you can just run shell commands to do what you need to do. And it's not always the cleanest way. It's not always the most idempotent way of doing it. But if you have to do a hack, it's there for you. Back to the idempotency promise. So something like make directory mkdir -p, it looks idempotent, right? If you do make dir -p /op/app, and then you chown it, and then you chmod it, if you rerun those commands, they redo everything. All the work gets done. Like the directory tries to be created again. The chown gets applied to the directory again. The chmod gets applied every time. And if you typo any of those, you've just broken something or you've changed the state. You also can't really tell what's changed from one run of those three commands to the other. But if you use the Ansible file module, you can give it a path of /op/apt. You can say the state should be a directory. You can set your owner and group information and your permissions. So you take those three shell commands and you turn them into an Ansible module in a task. And the first time you run it, it'll say changed one because one thing changed. It didn't, that file didn't exist. So Ansible created it and it set the permissions on it as we've described. And then if we run the playbook again, Ansible's like, well, it already has the path already exists. And then it looks and it says, okay, it's already a directory. And then its owner is deploy. Yep. And it goes through the checklist and it makes sure all those things are set. And it says, okay, one, change zero. So now you have this one source of truth for being able to tell when this thing changed, if it changed during your run, and you don't have to worry about typoing a command. And this is kind of like the smallest example. Everything from here on just kind of builds on this idea where we're using these modules, and the modules are built into our tasks, and our tasks are built into our roles, and our roles are built into playbooks. So it's this kind of compounding idea. So once we've got a role or two, or once you've got a couple of tasks working around doing things for you, the next thing you would probably want to do is work on grouping them together. So for our example tonight, we want to provision a bare metal Debian server. So we're going to write a playbook called server-setup.yaml. If you hate YAML, I hear you, but there's a lot of YAML in Ansible. And there's a lot of YAML. And if you absolutely hate YAML and you really want to look into Ansible, go into your favorite editor, PHP Storm, Vim, whatever it is, and find the setting that enables the white space indicators for you. And that may change your idea of how much you hate YAML. If you have struggle with white space issues with YAML, turn on those white space indicators on your editor. Makes it so much easier to work with. So what we're saying here in our server setup is we're going to call it, we're going to name it. We're just going to say provision a web server. We're going to run on a host group of named web servers, right? So this wouldn't apply to any of those DB servers that we would have in that other inventory we looked at. This also is going to say become true. This is an example of using become true where you're SSHing into a server that you may not be root on. You may be an unprivileged user that has sudo capabilities. You are going to need passwordless sudo to be able to use become. Without that, it breaks. All of this has to be essentially run non-interactively. So you're going to run this, and there's not going to be a way for a password prompt to come up. You have to figure out you have to configure the passwordless sudo to be able to use the become and to be able to do a lot of these more complex things. Then we're going to define a list of roles, and these roles are just groups of modules and tasks that we've grouped together to do specific things. Like I usually start out with a common role, and a common role will install very specific things like making sure Vim's installed, making sure something like NCDU to be able to find what's eating disk space is installed, creating any special setups or shell preferences that I have for my users, setting up firewall rules is typically what I would do in a common role. That way, you start with this common starting point of your role, and then your roles after that can configure it. So if you're using a database server, and our firewall is our common role sets up a firewall, you don't have to worry about going and saying, oh, well, what ports did that open? It didn't do anything. It just installed the firewall and set some basic defaults. Your further playbooks or your further roles down the line should go and change those. So if, for example, for MariaDB, if we need to open the ports for MariaDB, we should do that. We should adjust the firewall rules within the MariaDB. And that's just one way of kind of thinking about grouping your logic. You want to configure and install the MariaDB service. You want to configure and install PHP and Nginx. Let's separate those out, and we can contain those logic and those files together. And this directory structure at the bottom here is very kind of Ansible convention. If you use the Ansible convention, everything will work. If you don't, it'll have a hard time finding things. So in a role folder, for example, our PHP one that we have, there's another subfolder in that folder called tasks, and there's a main.yaml, and that's what to do. What are we doing in this role? You can also have a handlers folder with another main.yaml. You'll see the convention here of the default file that Ansible looks at in these folders is always going to be called main.yaml. If your logic gets too complex, you can split that up into multiple files and include them. You can also do conditional includes. The next folder we have in our example here is a template. So this is how we could template out what we want for our PHP INI on the remote server. And then we also have defaults, and these are our role level defaults. These would be variables. So any variables that would be scoped to just the installation and configuration of PHP would be in our role. And if they're scoped larger than just the role, we can put them elsewhere in our playbook. So the kind of first hello world ad hoc command that Ansible that you typically run is Ansible-I, which is to specify an inventory file. And in this example, we're just using inventory.ini, and all is a keyword to where it runs the command against all of the hosts in the inventory. And then we're going to use the Ansible module ping and call that via -m for module and say ping. When we run that against our inventory, what we'll see is the host name itself, the host that was connected to was web01, and we'll see the result of that ping. What we should always get back is Pong and changed false, and then you can see the Ansible facts that were discovered through that run. So as long as it's green, you're ready to write real plays. So let's build a real PHP stack. Like I said, I use Laravel here because the application that we're going to end up with is a Laravel app. It doesn't matter. Any modern PHP, any old legacy PHP, you can build it with Ansible too. All you need to know is the shell commands on how to set it up, and you can write a playbook to do that for you. So this isn't even limited to modern systems. So what we're going to build is a Debian 13 web server provisioned entirely from our playbook. We're going to have an app that lives at home app user app current. And then we're going to have a releases folder, and we're going to be able to do the zero downtime deployments by rotating the symlink to current so that we can deploy our application and not have any downtime. So this is going to be Nginx PHP 8.4. We're going to grab PHP from the deb-suri package PPA from Ubuntu, from Debian. We're going to install MariaDB. We're going to use Valkey for our cache and our queue. We're going to use Node LTS to do our asset builds. And the application that we're using is the PHP Tech 2026 site because it's still public. We haven't publicized the 2027 site, and it's running Laravel 12. So this is where this is our goal. This is what we're building. So our role anatomy is kind of what we talked about a second ago, is this roles folder. And in this example, we're covering our PHP. You have the tasks, that's the what. The handlers are the reload and restart triggers. So if we update our PHP configuration, we should restart PHP. If we don't update our PHP configuration, we shouldn't restart PHP. This allows us to only restart the services that need to be restarted. And you do that with handlers, and we'll cover that. Templates, we'll have a PHP INI template, and we'll also have a configuration file for our Laravel application. And if we need any static files in the server, we can just copy those out of a files folder. And then for all of our role level variables, we'll keep those in the defaults /main.yaml. So this stack is 7 roles is what you would kind of break this up apart at. And you can go through, you can create user accounts, set up the actual users, MariaDB, PHP. Essentially, this is just the separation of concerns, right? Separating the different services that we're going to need and isolating what it takes to install and configure each of those. So if we can take a look at parts of the PHP role, we can see what's happening. And this syntax is a little bit weird because I'm trying to condense this very long line into a block. So it won't always look this weird for you when you're writing this yourselves. But what we're doing is we're using the apt repository module to install the deb-suri PPA for Ubuntu and Debian Linux. We're going to specify the file name, and we're going to update the cache, which is going to do an apt update. So what we're going to do in that first step is it's going to install the keyring, install the package source, and then it's going to do apt update. So all those packages will then be available. And then in our next step, we'll be able to use the app module to install the specific PHP packages that we want. Similar for MariaDB, what we can do is we can lock down MariaDB to where we only have it listen to localhost, and we can do that with a line and file module. And this line and file module is really powerful because you can give it a path and a regex and a replacement line. So whatever bind address is set to in that file, we don't care. We're going to find that line that regex matches, and then we're going to replace it with the contents of what's in the line in our module here. And then because we're changing our MariaDB configuration, we're going to notify a handler that we have called restart MariaDB. And when we notify that, that tells Ansible, hey, we have a pending service we want to restart. Wait till the end of the playbook run and then run all of our handlers. That way you don't restart MariaDB here and then have to restart it in 5 seconds later when you need to do something else or maybe another configuration change. So that way you're minimizing the thrashing of your service restarts and you're making everything as efficient as it can be because you're not wasting time waiting for those services to restart. The next thing we might do is create our application database, and we'll use the MySQL DB module for that. And we can also use that same module or another module for MySQL user to make sure that the anonymous user isn't there, right? So this is just kind of a very basic locking down our server in preparation for our application. The Nginx role, we can use the file module to delete the default sites that's enabled. Then we'll notify Nginx to be reloaded. That's another handler for us. And then we have a third handler that is reloading PHP FPM. So if we need to update the PHP pool user to our application user, the first time this playbook runs, this will run. The next time it'll already be set and it'll skip it. So the first time it'll reload Nginx, it'll reload PHP, but the consecutive runs won't because those things will already be set. We also have the render our application virtual host, which is just creating our Nginx configuration for our host, and then we reload Nginx. These are all those notify are just handlers, and those are only going to restart those services if those files have changed. So the handlers are a reload only if it changed. So in our edit PHP ini task, if the contents of the file changed, then we'll queue a reload PHP FPM. And then at the end of the play, Ansible flushes all of its handlers, and then our systemctl reload PHP FPM gets called. If nothing has changed in our PHP ini, nothing gets queued, nothing happens, the service stays running. So this is just a very easy programmatic way to only restart services when we need to. And for this example, we can run it and then we can run it again. The first time we run it, you're going to get a lot of changed equals ones. That's the server is actually being built. And then the second time you run it, you're going to get okay and then change 0. And then this is the idempotency. This is the being able to run this playbook over and over and not breaking anything, and always knowing that the desired state is going to be what's actually on the server when the playbook finishes. And at this point, our application doesn't work. It's still going to 404 if we go to our host because we actually haven't configured our application yet. So an example running this from the command line is you'll see all the yellow text. That's things being changed. So that's our common playbook being our common role being run in our playbook. And we're installing our base packages. And you can see we have 2 web hosts that we're running this against. We're running it against Web 01 and Web 02. And then we see we're allowing SSH into the firewall. We're doing some default denies. We're creating our application user. We're ensuring our application user is home, is traversable by the web server. And then we're installing SSH keys. And those are being skipped there. They're in the teal color because the SSH keys that I'm installing are the ones that are already installed that were baked into the image. So nothing needs to happen. So nothing changes. And then once this finishes, we can run it again and you'll see all of that yellow goes to green. So all of these things have already been done. We've already made these firewall rule changes. We've already set these paths. We've already configured these things. So there's no reason to do anything again. So this second run happens much faster because we're not having to stop and do things. So the other advantage of this is the subsequent runs of your playbook should be pretty speedy because you're not doing everything. So the real payoff of this kind of what we're wanting to get here is this zero downtime deployment. And we want to be able to have multiple releases. We want to have a symlink that switches between them. And we want it to be very fast and not have to worry about draining connections or a user being redirected to the wrong version. And we also want to be able to roll back as quickly as we possibly can. So first off, when I gave this talk at my local user group, I really blew some minds with symbolic links. So I wanted to add a little bit more in case somebody here is just now hearing about what a symbolic link is. We call them symlinks. Most commonly, they're referred to as symlink. They're a file whose contents is a path to somewhere else. Think of this as a desktop shortcut. You place a desktop shortcut on your desktop and you double click on it and it takes you somewhere else on your file system, or it launches an application, or it takes you somewhere, right? That symlink is just a link to somewhere else. So what we're going to use it for is we're going to use it to specify releases that are time stamped or date stamped, and we're going to symlink that to a current folder, and we're going to point our web server at the current folder. This means when we deploy our application, we don't have to restart our web server. Excuse me. We don't have to restart our web server. We just have to update that symlink of where the web server is being pointed. So this release directory pattern is really, really common. And if you're using any service today that does this that does deployments for you, this is essentially the pattern that they're probably using in some form or fashion. So what this means is we have our current symlink, and that points to the current release. But we don't want to duplicate our env, and most importantly, we don't want to duplicate any storage we have. If we have any storage on each application server, such as basic images, or even if you have a legacy application that still throws everything in your storage folder, you don't want to keep creating new copies of that and eating up disk space for each release you do. So what we do is we create symlinks to our env in our storage folders, so that every time a release is swapped out, they're not swapped. They are still pointing at wherever those files are actually living on the host, which is in our application folder. So there's 4 guarantees that we get out of this. Current is always going to be a fully built, migrated, and asset compiled release. Swapping that current link is one system call. There's no torn state. There's no half deployed window. There's no crippled application. There's nothing halfway done. There's no question of the state that anything is in. Our .env and our storage folders always survive deployments because they're in a shared folder that is symlinked into our application release folders. And our rollback point is we can point current at any of the previous releases and reload, and the application will be back to that state. The only time that obviously that you're probably thinking, well, what about migrations? Well, if you don't write down migrations, then you might have a bad time. You may have to do something or be able to account for migration state differences if you have to do a rollback. That's why a lot of people don't do down. They don't run down migrations anymore. They always, if something breaks, they fail forward. They fix it forward. So that's always an option as well, depending on your business needs and the reliability that you have to have for your application. Oh, that was the wrong button. Oh, I've skipped it. I went back a few slides. One second. Here we go. Let's catch up. Okay, symbolic link, our strategy pattern. There are 4 guarantees. Why the swap is atomic. This is an operating system thing. This is one system call in your operating system, and it's atomic. So if a request comes in the middle of this happening, it will actually get blocked, and then the symlink update will go through, and then the request will come through to the new application. So even during a deployment, if somebody tries to access your application, they will get blocked, and then as soon as the system call is done, which is almost instantaneous, they'll get unblocked, and their request will get fed to the new version of the release that was just updated or just installed or set to current. If this pattern sounds familiar, it's because it's very familiar. This is the Capistrano pattern. It was made popular by Rails around 2006. A lot of tooling duplicated this. This is, it's one of those things that somebody had a great idea, and a lot of people just ran with it. And it's a great way to get this very beneficial zero downtime deployment for your application. So our application role, this is the role that needs to do a lot of prep, a lot of build, and then it has to go live. So it's going to compute the release name. It needs to ensure the folders exist. It needs to render an env file. It needs to clone our repo. It needs to symlink things around. And then it needs to also build the application. It needs to run Composer, NPM. It needs to run migrations. It needs to be able to automatically swap and notify and restart services if needed. And it also needs to prune releases. In our example, we'll keep the last 5, but you can keep all of them if you need to. It's just disk space. So the application role, and I'm going to step through these relatively quickly. If anybody has questions, please feel free to drop them in the chat, and I will get to them as I can. But we're going to go through this. This is the full application role of what would actually work and what I have in my demo and what was actually done in the tutorial when I did this. So we start out by computing the release name, and we're using the set fact module here to just set a fact that will be available through the rest of the playbook. And it's going to be called release path. And this is how we create our release folder based on the ISO 8601 basic short for date time. And then we're going to ensure these folders exist. And then we're going to set up our Laravel folders. And this is the first example I think of where we're actually going to pass in, or we're going to see a loop. So we see this loop mechanism here. So what happens here is for every item in this list, this module will get run. So it's going to get run for app, and it's going to get run for app public and framework. And wherever you see item is where the list item gets substituted. So it's going to use the file module to set the path, and they're going to be directories, and they're going to be owned and grouped by our application user. So it's going to create each one of those folders for us. And then next, we're going to render our env using our template module, and it's going to, our source file is our env.j2 file for the Jinja 2 syntax. Then we're going to give it a destination, ownership information, and a mode because we want this to be locked down. Next, we need to clone our application. So we'll use the get module, and then we'll symlink our env into the shared release with the file module. The next thing we want to do is remove our in repo storage directory and symlink our shared folder in here. So when we cloned our repo, we have that storage folder, but that's not actually where our storage needs to live. So we'll symlink in where our storage actually lives on the server into the release. The next thing we need to do is run a composer install. So we'll use the composer module. We'll give it command install. The release path is our working directory, and we'll say no dev true. And we want to optimize the autoloader as true as well. So we only get our production dependencies. The next step is install our node dependencies and build our front end assets. We'll use because we don't have, or there, I'm not sure if there is a npm module. I've never seen one used. I've always seen it used as these built-in commands, this command module. The command module is great because that's also what was on the Apollo, right? It's the command module. And the command module can do anything that you can do on a shell. So if you need to do npm CI, you can just run the command module, tell it to do npm CI, and you can pass in, we're using the change directory for the release path to make sure we're running npm CI from the right path. And then the same thing for running npm build using that command module. The next thing is to run our database migrations. And because we're going to be running this in a production environment, we need to use the force flag. So we'll use the command, the Ansible built-in command module as well. And then we'll set our cache config routes and views. And we're going to loop over those and run those 3 artisan commands to configure our cache, to cache our routes, and to cache our views. The next thing is to set up our queue worker, and that's where our Laravel queue service comes in. Our Jinja 2 template, we're going to set that into as a systemd service, and then we'll notify our restart Laravel queue handler to restart our service. And then we'll enable and start it so that it starts whenever the system reboots if needed. The last thing we'll do is we'll actually do the atomic swap of the symlink. And this is where we take the old current and pass it onto the new current path for the release. And then we notify both of our reload FPM handlers and our restart Laravel queue to where they start serving from the updated path. We can also prune our older releases, and we can do that with a little shell script You can do these inline shell scripts here, or you can copy files, shell scripts to the server and run them. For small scripts like this, I don't mind the inline piping here of it. For much more than like 3 or 4 lines, I would typically write a script and then have it copied to the remote server and executed from there, just because I think that's a little bit cleaner in the Ansible playbooks as opposed to having this pipe with a ton of lines of code. It makes it a little harder to read in Ansible. So the two gotchas that we talked about with Laravel applications, and just about any application you're going to have any kind of storage or pre-existing folder, you're going to need to handle that, right? And that's what we did is we removed those folders and we recreated them. Also, a app key must exist. So when you're setting this up for the first time, you want to make sure that all of your information is in your env and in the variables so that your env gets created and you don't try to run it without an app key. So those are just two little gotchas that I've seen a lot of people run into. So the deployment here is essentially rerunning the playbook. We can copy all of that, all of the tasks that are just in the application role, and we can create a new playbook called deploy. And the first time when we set up our server, we run our server setup playbook. And then after that, if we're only going to deploy the application, we can run the deploy, which is just a much smaller set of information. There's no reason to reinstall PHP if we haven't changed any of those things and we're just trying to deploy our application. We don't want to reinstall PHP. We don't want to try to install MySQL or any of those other things because we know they're already there. So how do we operate it safely? How do we handle secrets and patching? Always a concern. So Ansible has a secrets management system called Ansible Vault. These are one-way hashing. So if you lose your password, it's going to be very hard to get this data back. So make sure you're saving your Ansible Vault password somewhere securely. There's a couple different ways of doing this. What we can do is we can create an Ansible vault using this first command, Ansible vault create, and we're going to create a vault at a folder called group vars, web servers, and a vault. And that's encrypted at rest. That entire file will be encrypted, and then we can use Ansible vault edit to edit that file, and that will open it up in your whatever your console's text editor is. If that's Vim, Emacs, anything you have it set to, it'll open in that. You can save your file, and then when you save it, it handles that for you as well. Then you can run the server. When you run the playbook, it's decrypted automatically because you have an Ansible configuration file that has wired up where the password is. And this convention gives you these two files side by side. You have a vault file that is committed and is encrypted. And then you have your vars file, which is plain text, but it's committed. So what this is doing is it's setting this DB password variable to the vault DB password. And that vault DB password is sourced from the vault. So our encrypted vault.yaml holds the real secrets and it's safely committed to get. The plain text vars shows what exists, so diffs stay readable, and you have this audit ability to be able to look and see on this date and this commit and this PR, Joe changed the database password and everything broke. Let's go blame Joe. You can also have roles reference this. You want your roles to reference the DB password, the variable, never the vault DB password directly. And in CI, the vault password comes from a CI secret. There's no playbook changes. Nothing needs to happen. You just need to be able to pass that vault password securely to your CI/CD process. So patching is you're typically going to want it to be a separate playbook. So what we'll do is we'll create a new system update playbook. We'll run it against all of our hosts, and we'll run tasks, which are going to be our first task is going to be the apt module. We're going to do update cache true, and then we're going to say cache valid time 3600 seconds. So that's going to do an apt update, and it's going to run out to all of your sources and update all of the indexes for the packages that your system has available. This can be kind of slow, especially if you have a slow internet speed or you're going through multiple network hops to get to the server. This could be a slow process. So we don't want to do it immediately again. So we cache that valid time. So we're going to cache it for 5 minutes. The next thing we're going to do is we're going to do an upgrade dist, and then we're going to do auto remove true. So anything that needs to be auto removed will automatically be removed. Anything that needs to be updated will automatically be updated. We can also do what we're going to do next is in the event that our kernel was updated or some other package dropped this file on var run reboot required, indicating the system needs to be rebooted after apt runs, we can register that. So we'll stat that path and we'll register the output of that stat into the reboot required. So then when we can check for in the reboot module, we can check for when that reboot required stat exists, we'll reboot the system. So we can run this and see it run, and we'll see the first section gathers all the facts, and then we update the apt cache, and then we update all of our packages. And in this run, I'd already run this before, so the apt cache was still within 5 minutes, so it didn't actually do anything. So you see it's okay on both of those hosts, and it's green. And then we upgraded all the packages because the base VM I was using has been around for a couple months now. The packages were out of date, so it updated all the packages. It checked to see if there was a reboot required, and no reboot was required because the both of those lines say okay local, or sorry, okay, and they're green, so you don't have to worry about it. And we check then if a reboot of the library or the kernel demanded it, and it was skipped on both of the hosts because it wasn't set. So all of that is how we get our bare metal Debian server to the up and running with our application, installed, all of our dependencies installed, all of our services up and running, and how we can run that against one server. We can run it against 100 servers. It doesn't matter. So that's all a lot of academic stuff. What about some real world Ansible? Well, it turns out that PHP.net runs on what you just learned. So a lot of what we have, or what runs on the actual PHP infrastructure, is backed by Ansible, and you can see a lot of how it was done. You can see how the sausage was made by looking through the PHP infrastructure repo. So the goal here isn't to kind of to show you like any large, anything we haven't shown you before. I want to show you like the real world application impact and what this looks like for something like an organization like PHP. You can find this repo at github.com/php/infrastructure. Currently today there's 17 playbooks, there's about 15 roles. We manage 8 hosts, and there's about 512 commits. There are years in this repo. There's a handful of people who have spent a lot of time maintaining this repo. There's playbooks, there's roles, there's inventory, there's group vars. There's nothing new in this repo that we haven't covered in some form or fashion so far. So let's look at the inventory file. So the inventory file is specifying a number of different things here. What we do is we have jump hosts, we have rsync, and we have our service children. So the jump host group is what we use as bastion servers or jump hosts to get to the services behind them, because you can't SSH directly into those servers. So the jump host 0 is an alias, and the Ansible host carries that real name based on the variables. And yeah, Ansible Galaxy, I'll cover that here in a little bit for where to go from here. Ansible Galaxy is what you can use to source roles and playbooks written by other people. Most notably, Jeff Gerling guy from the Drupal community, has written dozens and dozens of playbooks for multiple operating systems and different things where you can just go leverage his playbooks. And he's also has a fantastic book, but we'll cover Galaxy here shortly. So the other service group here that we're doing is service children. This is a group of groups where you can use limit service to run them only on specific services. And the services are actually broken out into their own hosts. So we have the museum service, which is actually service 8 as the host. And you can see we set our Ansible hosts and we set PHP versions on these. We are in the process of migrating all of these hosts to Debian 13 and thus giving us PHP 8.4 out of the box. The analytics server is one of the last ones that we haven't migrated yet. And when I say we, Derek Rethens is doing much more of the migration than I am. I've been recently helping out with some playbook stuff and testing some different things that he's been working on. He's the one that does most of the infrastructure work. If you've ever been curious on who manages that, it's Derek. So service 4 is still running on PHP version 8.2. So what we can do is we can use that PHP version later in playbooks, and that's how we specify what version of PHP we install. And that's just one way of doing that. You could do all kinds of conditions in the PHP role on how you install PHP. This was just the most straightforward way of, we wanted to make sure that hosts were being assigned the right version of PHP that we expected to be in that version of Debian. So Debian 12 has 8.2, Debian 13 has 8.4. So you can't SSH to those service boxes. This is where those jump hosts come in. The Ansible configuration, the ansible.cfg, is what we use to set up a lot of these options, and then we also use this etc ssh config jump, and this is committed, so you can update this to your user, and it allows you to do shortcuts to be able to jump through the jump host, to be able to run Ansible pipelines behind the jump hosts, to be able to access those servers. So this is an example of, if you need a jump host, or if you have a Bastion server that you need to use, Ansible has no problems doing that. It has tons of different ways that you can configure this for your specific environment, your specific needs, to be able to get through those, jump through those hoops. Secrets. There is another way of doing the secrets, and the PHP.net project doesn't do the secrets like we showed you a few minutes ago, where we have the vault and the secrets file. Instead, the vault and the secrets are all the one file, and the entire file is encrypted at rest. And on the left here, you'll see, if you go into that file in the repo, you'll see this Ansible vault, and you'll see this encryption. That's the entire file encrypted at rest. I think it's 118 lines, something right now. And then what you can look at is the all.yaml, the skeleton. This is also committed. This is what that is actually representing without the values. So if you're needing to figure out where a variable is coming from, you can look at the all skeleton if you don't have the encryption key, because you don't need the encryption key to work with this, to just go and browse this repo. You only need the encryption key to the vault if you're actually applying these and running these playbooks on against the actual live PHP infrastructure. I actually set up all this infrastructure on my own Proxmox host locally on my own network, created my own vault key, and have no problem running it like that, because I didn't need the PHP vault key to do anything with what I was doing, running it all locally. So earlier we showed you the vault and the vars and that indirection. PHP.NET encrypts the entire file and then commits the skeleton as the human readable contract. The trade-off is you can't diff that all.yaml. The other trade-off is it's a little bit easier to just edit that one file that's encrypted at rest and save it and get in and out. So that convenience factor kind of outweighs the explicitness and the auditability. It just depends on what your organization needs. So why production bends the rules, and some of the things that the PHP.NET playbooks do is different than what I was showing you. And the reason is what we want to cover. So what we showed you earlier is using fully qualified collection names. So using ansible.builtin.apt. The PHP.NET project just uses apt, file, and user. The repo predates this collection split, rewriting the 15 roles for zero behavior changes, churn, with regression risk. Ultimately, there's a lot of find and replace that needs to happen to update this to be more modern Ansible, but it's just, there's bigger things and more important things to do right now. Honestly, within the PHP infrastructure project, if you're just looking at from a aspect of what's going on in the infrastructure world, there's just more important things to do. The idempotency and the safe to run, the PHP.NET project actually has a big initialized service that runs once because it needs to configure the jump hosts, and that run happens in a very different configuration than everything else does, because that configuration doesn't need to go through a jump host, because you're actually provisioning the jump host with that playbook. So it also disables a lot of security and things, and turns off a lot of security things on the services behind the jump hosts, so that you can't directly connect to them. So you run that once, and then you typically never run that again unless you're spinning up a new service or spinning up a new server. The next difference is the vault and vars difference versus the whole file and a skeleton file. It's 25 values. They're rarely rotated. They're read by many hosts, but they're not read by many humans. So there's a lot fewer moving parts. It's not important, right? It's all trade-offs. I taught you to automate the scary steps. PHP has very explicitly, when you need to run this playbook, comment out the section, and when you're done, comment it back out. And that's just because we're having to configure our jump hosts that we can't proxy to a box that hasn't been initialized yet. So this happens once per host every several years. So these are acceptable paper cuts that don't really mean a lot to the PHP project as it stands compared to what else needs to be done and other things that are going on. So these are things, these are not laws, right? These are rules, these are guidelines. Use them to and bend them to what makes sense to you and your project. Excuse me. So where to go next? If you want to start exploring what's possible with Ansible, and you don't want to start writing your own playbooks, or you just want to see how other people are writing playbooks, you can do Ansible Galaxy install girlingguy.roll or whatever namespace.roll, and it will copy into your project. And you don't have to copy paste that. You don't have to maintain that code. If you are doing some very generalized server and very standard, like rubber stamping server configurations, go look at Jeff Gerling's roles. They will help. They will jumpstart you and put you months of progress down the road compared to having to write your own playbooks. They're really top notch uh, roles and tasks, and that will give you a great idea of how to do the things that you need to do. The next thing on where to go next is in the world of treating your servers like cattle and not pets. Dynamic inventory allows you to build your hosts from a cloud API, whether that's DigitalOcean's API or AWS, Azure, whoever's API. This allows you to have auto scaling. Your IPs come and go, but your Ansible playbook can always run a dynamic inventory script to build the host that exists at that point in time. You may have servers, a fleet of servers that scale up to 50 during the day and they scale down to 10 during the night. You only want to run your playbooks against those 10 servers at night because those are the only ones that exist, right? The auto scaling, and you don't want to have the static configuration of those servers in your inventory be stale when those hosts are auto rotated in and out. AWX and Ansible AAP, Ansible Automation Platform. These are essentially web URIs with access control and isolation and scheduling. So once you have more than one or two people running your playbooks, you definitely want to look into something like AWX, which is the free open source version of Ansible Automation Platform. Ansible Automation Platform is Red Hat's product that they sell you. That if you want Ansible, that's essentially where they start you out with. And I believe there is an evaluation version. You can go get that and play with that for nearly cheap or nearly nothing. I believe they also have a developer program that you can get servers licenses for free up to a certain amount. So they've really done a lot very quietly over the past several years to kind of help adoption for developers looking for other platforms to work on. Molecule is a testing framework for roles. And I want to talk about testing because in the PHP community, we have several testing evangelists. It's been drilled into everybody of you test your code, you test your code. I spent a lot of time at a previous job trying to write molecule tests for our infrastructure for our playbooks. And ultimately, it was way too much work and it wasn't worth the effort to write those tests because it was so heavy. There was a lot that goes into it. There's a lot of setup, there's a lot of teardown, there's a lot of what goes into the actual test runs. And it was just very brittle for the value it was giving me when I could just run a playbook against a staging environment and verify it works and then throw that staging environment away and recreate it. So at a certain scale, molecule is incredibly important and incredibly helpful. Like a lot of the roles that Jeff Gerling writes has molecule tests because so many people are using those. He needs to be able to have a way to test those changes and understand what's happening in changes and be able to prove that they work. In my work, I haven't reached that scale yet, and it's just I've never been in a situation where that trade-off is there. So don't quote me as saying you don't have to test your Ansible stuff. You should. I'm saying that you may not need to run molecule tests if what you're doing is running tests against a live server and then throwing that live server away once you validate the the test worked. So in that regard, what I'm advocating is at a certain scale, manual testing is going to be a lot more valuable and efficient than automated testing, given the work that has to go into the automation testing aspect of Ansible. You can also have CI integration. You can have your GitLab actions, your GitLab CI/CD, your favorite GitLab or your favorite CI/CD platform. You can deploy when you push. You can have the vault password come from a CI secret, so you can run your playbooks and your actions. Also, when you get up to a certain number of hosts, you can start doing rolling deployments, and you can use the serial keyword to be able to say, all right, we have 100 servers. I want to run this playbook and I want to run serial 10. So it'll run 10 hosts at a time, and it'll grab the next 10 hosts and it'll run and it'll grab the next 10 hosts. This is an easy way to avoid a fleet wide outage, right? You're only upgrading part of your fleet at a time. It helps you be able to do blue green deployment so you can verify that those hosts take the updates and nothing explodes, nothing falls over. Because if it does, Ansible will stop and say, "Hey, there was this problem. This is what we couldn't do." So, what all of this gets us is the ability to provision. We can describe our server as code, and it's agentless over SSH. It allows us to compose. Every layer of our stack is a reusable role. It allows us to deploy. We can build a new release. We can flip an atomic symlink. Finally, it allows us to operate. Our secrets are in vault. Patching is its own playbook. Any task that we need to do, we describe it as a playbook, and we iterate on that playbook and what it's doing. We go from go do this task to this declarative format of this is what we expect, this is how it should be. So if you have a coworker that comes in and tinkers with something, and all of a sudden this one server is acting weird, you can go run your Ansible playbooks, and that will reset potentially what they tinkered with, because what you're doing is you're taking your described state and you're applying it to what it should be. So you remove that drift of people going in and installing PHP from different sources. It's always being installed from the same source. And with that, that's most of what I have. I've got a couple of Q&A things, but if anybody has any questions, feel free to throw them in the chat and I will get to them. While people are thinking about their questions, I want to cover a couple of things that tend to come up when I talk about Ansible, and it's Windows hosts. Can you use Ansible with Windows? And the answer is yes. You need WinRM though. So you also will need PyWinRM in your control node on the Windows machine that you're running your playbooks from. You'll need that. But you can do stuff like use the Win feature module that will ensure IIS is installed. You can also copy files with the Win copy. So all of those things that we just did against a Linux Debian server, you can do with Windows. You just have to make the accommodations. And you have to figure out what the modules are on the Windows side to do that. The other question I get a lot is, what about Docker Kubernetes? Kind of the first question is, what if the host is running containers? And Ansible is great. You can provision Docker. You can configure your systemd units for your compose stack. You can have Ansible run your compose commands to update your stack, to pull your images, to even build your images. You can use Ansible for all of those things. The containers themselves, you really want to prefer the orchestrator's primitives. So you don't really want to like use Ansible to provision a container. You want to use a Docker file for that container image build. Use the right tool for the job. You can use Kubernetes manifest. You can use Helm customize for deploy. At a previous job, we used Helm and customize heavily within our Kubernetes clusters, and we used Ansible to manage all of it, except for the actual cluster configuration, which we used a different tool called Pulumi for that, just to create the infrastructure. And then we used Ansible to provision and deploy applications and manage everything. The last thing I have is our rollback strategy. One of the things that we didn't cover is if we know what our application revision is, what we can do is we can go say Ansible playbook, run our inventory, and then our deploy, and then we can pass in an extra variable and we can pass in a version. And what that'll do is allow us to roll back within our playbook to be able to revert. So we did a deployment, something went horribly wrong, somebody's PR got in there that didn't need to go, so we roll back. So this is how you would do that rollback. Or if that's not fast enough for you, if you're having to firefight and you're already on the host, you can just flip the symlink back. You can just go back to one of the previous releases, then reload your PHP PM and your restart your Laravel queue. And then our releases, based on how we've built this, retains the last 5. Tune that with a step for a longer rollback window. If you need more rollback windows than that, then that's up to you. Again, that's all just disk space, right? It's just as big as your application is. As long as you have the disk space to handle 50 releases in that folder, you're perfectly fine. And that's everything I have. Thanks for attending. Thanks for watching.
All right. So I'm been nudging folks in chat. I think the one question that did come up, you actually covered by mentioning Galaxy. So nice getting ahead of that. And likewise, you covered the question that I was thinking of potentially asking around, like, okay, is this the right tool for the job for things that live inside containers in kind of immutable infrastructure? And that is kind of a different paradigm. And this is complementary to that, but you don't want to fiddle with necessarily doing this when it's like, well, you could just do the immutable thing.
Yeah, it's real easy to learn a little bit of Ansible and say, all right, I have a hammer and everything's a nail, right? And you can start doing some things in Kubernetes that don't really make a lot of sense. You can deploy an SSH files and or copy files into running containers and doing weird stuff like that, or not standard Docker stuff like that. So you can get into trouble doing that with any tool, right? So it definitely is the right tool for the job.
Cool. Well, thanks so much for presenting this. One question that just came in. How about using this with Vagrant?
You can 100% use Ansible as a provisioner for Vagrant. It has been a supported provisioning in Vagrant for as long as I've been using Vagrant, and that's been a really long time. So yeah, you can provision your Vagrant machines with Ansible just like you would Puppet, Chef, or shell scripts. How do I deal with variables and their precedent issues between default group? Yeah, see, you're touching on the thing that I glossed over. I want to say there's an XKCD for it, but I don't think there actually is. There are approximately 3,000 places you could define an Ansible variable. Not quite that many. You can define an Ansible variable in many different places. You can define it in the inventory file. You can define it in the role in the defaults file. You can define it in a group vars folder, in a vault, like what we saw with our encryption. There is a pyramid graph that is in the Ansible documentation that I always refer to on where variables, or the essentially the precedence and preference order of where variables get sourced from, and how I successfully avoid having to reference that many times, and every time I touch Ansible, is I try to scope my variables to the smallest unit. So if a variable is only used in the PHP role to install and configure PHP, it goes into that role. If it's a API key that multiple servers need, I will put it in the group vars file, because that's where the most common folder is, or the most common place for that to be. If it's something that is affecting only one specific host, like what we saw with the PHP infrastructure, we saw setting PHP versions on the inventory file. That's also a completely valid and useful way to set them. I try not to set variables outside of those places because you can get yourself into trouble. It's this resolution order of where to or how they're sorted and how they're essentially compiled and what their scope is. So you can get yourself into a lot of dangers. Try to stick to the closest unit that you need the variable, and you'll be in much better shape.
And probably also try to stick to the defaults rather than setting like role vars files if you can.
Yeah, absolutely. The defaults are very, very powerful, and how you can kind of how you can set the precedents for what those are. I'm going to drop a link in the YouTube chat. Actually, let me do this too. So this is the URL. Let me throw that. I don't have YouTube chat in handy right now. This is the controlling how Ansible behaves, the precedence rules, the precedence categories, where your configuration settings are, how your command lines, your configuration, where you can set your variables, and then the command line options. This is the page I was talking about on where you would reference if you're not sure where to put a variable, reference this. Or if you're not sure where or how a variable is being resolved, check this documentation as well. Super helpful.
Awesome. Yeah, and I just threw the link in the chat there.
Okay, perfect. Thank you.
So, all right. Well, thanks so much for presenting, and thanks to everybody who is watching this either online or in person, whether live or time shifted on either YouTube or phpc.tv. Have a good rest of your evening, and we'll be back here same time of month, same time of day to talk about jujitsu, the Git replacement in August.